So I just finished up with office hours here earlier, and this question came up a few times, so I wanted to put together a quick video to help out with others that might have the same question. So the upper right-hand corner, we've got the structure of caffeine. We've got a few questions based on that. Question 6, what is the molecular geometry, expected bond angles, and hybridization of carbon-6 in the structure of caffeine? Carbon-6 is right here. Carbon-6 has 3 electron domains, and all 3 of those electron domains are bonding domains. So that would put us in the trigonal planar electron domain geometry. Because we're trigonal planar, right, the best arrangement would be 120 degrees apart. And because we have 3 electron domains, we need 3 hybrid orbitals. So I'd have to mix together 1 s orbital and 2 p orbitals, right, to make 3 hybrid orbitals that are all sp2. So sp2 hybridization. Question 7, what is the molecular geometry, expected bond angles, and hybridization of nitrogen-3? So nitrogen-3 is right here. We have 4 electron domains, 1, 2, 3, and the lone pair make 4. So 4 electron domains, 3 are bonding, 1 is non-bonding. So if we go to that table and look, 4 electron domains is tetrahedral. Because we have 4 electron domains, I need 4 hybrid orbitals. So I need an s orbital and 3 p orbitals to give me 4 hybrid orbitals that are all sp3. So that's my hybridization, right? Because the tetrahedral geometry, I would be 109.5. And then my molecular geometry, I have 4 domains, 3 are bonding. So my electron domain geometry is tetrahedral. My molecular, so just looking at the bonds that I have, my molecular geometry is trigonal pyramidal. Right, so we should be able to do that by just looking at the atom, looking at how many bonds are around that atom, how many lone pair electrons are around that atom to determine the total number of electron domains around that central atom. We use that total number to determine the hybridization, and then also we can determine the bond angles and the electron domain and molecular geometry. Question 9 and 10 are kind of related to that. And so question 9 is asking us regarding the nitrogen number 1, what orbital overlap to form the sigma bond between nitrogen 1 and carbon 2. So this sigma bond right here, what orbitals are used to form that sigma bond? And to answer that question, we need to know the hybridization of nitrogen 1 and the hybridization of carbon 2. So nitrogen 1, I have 4 electron domains, right? I have 1, 2, 3, and then here's my 4th electron domain. So 4 electron domains, right? sp3 hybridized. Carbon 2, I have 3 electron domains, right? This double bond is a domain, this single bond is a domain, and this single bond is a domain. So 3 electron domains. To have 3 electron domains, I need 3 hybrid orbitals, so s orbital plus 2 p orbitals, I'm sp2. So based on that, I would need the overlap of an sp3 orbital from nitrogen to overlap with an sp2 orbital from carbon to make that carbon-nitrogen sigma bond. And now question 10, regarding nitrogen number 1, in what orbital are the lone pair electrons assigned to? Well, I know that I have 4 electron domains, and based on that, the hybridization is sp3. So that means my bonding domains are sp3 hybrid orbitals, and my lone pair, my non-bonding domain of electrons, is also an sp3 hybrid orbital. So hopefully that helps with question 10 and 9 and the 2 questions before that, but we should be comfortable with looking at a molecule like this, counting electron domains, and then determining, based on the electron domains, what is the hybridization, what is the molecular geometry, what is the electron domain geometry and what are the bond angles of that molecule, as well as determining, based on all of that, what orbitals are used, what orbitals overlap, right, to create the bonds that we're observing, both the sigma and the pi bonds.